Well, now I want to turn to Bob Gilmacher, who's going to talk to us today about 3D printing. Bob, welcome.
Okay, we're going to talk about 3D printing tonight, and my goal is not to teach you how to do 3D printing. It's basically to whet your interest. And I'd like to divide the presentation into two parts. Tonight's part is to talk about some of the equipment that you need for 3D printing and some of the things you can do. And then in a next session, which hopefully will be next week, we'll talk about some more practical applications of 3D printing and what you can do to further the hobby. Okay, now it's not going to work. Okay, for me, 3D printing at first was more of a curiosity. I had seen a lot of information about it, and I was just kind of curious what it would do for me and the hobby. Um, but as it turns out, and I think a lot of us are in the same position, that it seems like that we never have exactly the right part when we need that part. And a good example of that are like washers and spacers and bushings and clamps and special applications. I've had any number of cases where I needed to raise something or lower something. And I found that with a little bit of ingenuity, all these things can be made and not be purchased. Most of the time when I go to a hardware store, I can't find exactly what I'm looking for anyway. The other thing, and this is more the practical side, is that we can make our own rolling stock. And these are just three of the gondolas. These are about 12-foot ON30 gondolas. I have some 2-axle and some 4-axle, but we're expanding that line. We're not necessarily in the business of trying to sell this, but just to make have a really good piece of rolling stock. So when did this all start? And I'm not going to go down to every one of these. Let me click through them really quickly. But back in 1980, that's when people started thinking about 3D printing, and they wrote a paper on this topic called stereolithography. At that point, nothing was patented, but it basically laid the foundation for the 3D printing environment as we know it right now. And through the years, people got on the bandwagon and they did more research and actually built some machines. And finally, and we're going to talk about what FDM means in a minute, but the patent for some of the printers actually expired in 2009. And what that did was that it allowed anybody to get into the market, and it really expanded tremendously. For me, a crucial issue is that last point there was Prusa research. I have Prusa 3D printers, and I love them because they really last long, and they do a great job. So this is just kind of a time map of how things went and how the industry got started. So what makes a 3D printer a 3D printer? First of all, it has to be able to make a 3D object, and that's pretty obvious. But secondly, it does make that object by laying down layers. So everything that we see, whether it's this type of printer or another, we're going to talk about in a minute, very, very, very thin layers of material is laid down. And when I talk about thin layers, it could be anywhere from 0.2 millimeters all the way down to 25 microns, which is, 25 thousandths of a millimeter. Very, very, very thin layers. And lastly, it has to be an additive build process. One could talk about 3D printing in terms of like a CNC machine, but CNC machines are primarily a subtractive process where they have a piece of material and you're taking either metal away from it or you're taking wood away from it. In 3D printing, you start with virtually nothing and you actually build up the model. There are a lot of different 3D printers that are out on the market. There are a lot of different 3D printers that are available in industry. But from our standpoint as modelers, the two main types of 3D printers that we would be going after would be FDM, which is called fused disposition modeling. And the other one is SLA, stereolithography. And I'm going to talk about both of those in just a minute. The FDM printers, they start, and the best way to describe it to people that have no knowledge of 3D printing, it's sort of like running hot glue through a hot nozzle. Because what we're doing is we're using a very, very fine plastic filament, and we're running it through the hot nozzle. And that hot nozzle actually melts the filament and then lays it down in a Cartesian coordinate system based on the software that we use to design the thing. It builds layers from the bottom up, and I'm going to show you another picture of the Prusa. This is one of the Prusas. This is one of my older Prusas. But it builds on a build layer and a build plate, and that's what this area here is. That's the build plate. Most of the time, you can buy them fully assembled, or you can also buy them in kits. As it turns out, all the Prusas that I own, I bought them as kits. The nice thing about building something from a kit is you know how it came about. And then when you have to fix it, if you have to fix it, you have a much better understanding of what component you have to go after in order to get something fixed. A lot of the FDM printers you can buy for well under $400. As it turns out, the Prusas are kind of high end. They go for about $800. But from my standpoint, the investment is well worth it. And it's very easy to get started using the filament printer. And for me, if I were to recommend to anybody that wants to get into 3D printing, that maybe the filament printer is the best way to go. Here are some of the components associated with the printer. I mentioned before the build plate, and this is where everything is built up front. There's a filament that comes down through this hot end here, and there are several fans on it, but basically the temperature of the nozzle here gets up into the hundreds of degrees, melts the filament, and then it actually lays it down in a pattern that's dictated by the software that you use. Other things is the main control board is sitting back here. You can't see that too well. It's got a power supply, and then it's got an X-axis, a Y-axis, and a Z-axis. That's the reason why I said it works on the Cartesian coordinate system. And then all the controls for the Prusa are actually, and for many of the 3D printers, are actually a little either touchpad. This particular one is not a touchpad, but it's a touch screen that you can actually control how that machine is working. The filament that we put through the FDM printers, a wide variety, and not only the types, but also the colors. And I'm not going to go through all of these, but you can see that there's a wide variety of colors. The three that I use primarily, and I think most people use, are number one, PLA. PLA is I think it's polylactic acid that's made up. We use that. We also use PETG. I can't remember what the PETG stands for. And then ABS. ABS is something that I have never used, and it requires more of a controlled environment. So the PLA and the PETG are my go-to filaments. And this is a picture of how this machine works. So it's actually laying down that layer of plastic coming through that, and it's going back and forth, and it'll build up something that could be as high as about 200 millimeters high. Now, at this point, I usually run into a problem because this doesn't want to stop, so bear with me here. Let's see if we can get it out of there. Nope, not today. There we go. Okay. Along with the basic machines, you can have add-ons. I mentioned a Raspberry Pi and Octoprint. These are two add-ons. The Raspberry Pi is a small computer, and it allows me, or allows anyone that has these, to actually talk directly to the machine. The baseline machine for many of these, you actually have to create an SD card or a thumb drive, and you take and you plug it into the machine. That's how you get the file over to it. Using the Raspberry Pi and the Octoprint, that's all on my home network, and I can just communicate directly to my printers without actually having to go to them. You can also add cameras. This is an older camera, and what that allows you to do is it allows you to monitor the progress of your print from anywhere in your house. And I do that many, many times. I'll be upstairs watching TV. I might have a 4 or 5 hour print going on. The nice thing is, number one, I know when the print's done, but secondly, if the print should crash and you get a ball of spaghetti, and I know a couple of the guys have 3D printers and they probably know what I'm talking about. It's nice to be able to stop that as soon as you can. Otherwise, you have a very, very large ball of spaghetti if you let it go to completion. These are my two newest Prusas. These are MK4s. Here's a dongle that I put on there so that I still am taking the thumb drive or the SD card and plugging it into these. I haven't hooked these up to my local area network yet, although these MK4s actually come with built-in Wi-Fi capability. And it takes probably around 15 hours to build them, but it's very rewarding when you crank them up for the first time and they work. There's a number of different 3D printers sitting out on the market. Here's just a couple of them that you can see. This kind of is an oddball. It's an Anycubic Delta. Most of the other ones you can see have this squared off look, but I had a Anycubic Delta to begin with. I built it, could never get it to print, packed it up, sent it back to Amazon. They gave me full refund, and that's when I decided to make the jump to the Prusias. Okay, moving on to the other type, and that's the SLA printers. The SLA printers are an entirely different animal. Instead of working with that filament that melts, they work with a liquid that's ultraviolet sensitive, and it's an ultraviolet sensitive polymer, and that's the build material. So you're building from a liquid to a solid. The UV source sits down in the bottom of this chamber here. And again, when you use the software to design these, each layer is created in a mask, and that mask either lets the light go through or doesn't. And when the light does go through and contacts the UV or the UV sensitive material, a very thin layer, and a thin layer I'm talking about maybe 25 thousandths of a millimeter, is exposed. And then the build plate or the build plate lifts up, more fluid comes in, the next layer is exposed, and you keep building those layers up. Most of the time, these come fully assembled. So I've only known one that has a kit form. And again, there are many, many manufacturers out there to build these. This is a Elegoo Saturn. That's what I'm using. There are fewer parts on the Elegoo and fewer parts on the SLA printers than there are on any of the FDM printers. But the downside is this vat, and that's where that UV liquid sits, is very, very sensitive. And you have to be real, real careful that you don't rupture that vat, because if you do, then you have this fairly caustic liquid flowing down over everything, and you can basically destroy the printer if you're not careful. The nice thing about the SLA printers is you can get extremely good detail. Now, these are not model railroad related. I pulled these off the web, but many, many of the folks that are into creating miniatures and wargaming, they love the SLA printers because you can get the kind of detail that you see here. Something that I did make, I wanted some lanterns for my ON30 layout. And at first, before I got my SLA printers, I was using the FDM printers, the Prusias. And, because these are so small, you don't see all of these irregularities. But when you start making them with the SLA printers, all of a sudden, all those irregularities go away, and you can get some extremely fine detail. Here are my two working SLA printers. This is a Elegoo Saturn 2. This is a newer Elegoo Saturn 3 Ultra, and it has probably twice the speed and twice the resolution as the one that's the red cover. The covers are primarily to protect you against the UV rays that are coming out of the bases here. And this yellow is by another manufacturer. It's called Anycubic, and this is a wash and cure machine. I'll talk about it in a little bit, but after you're finished with an SLA print, it still has some of the liquid resin on the outside, so you have to be able to clean it, and you also have to be able to cure the final product, and that's what that machine will do for you. And again, there are many SLA printers out on the market. You can see a few of them here. Okay, so just a comparison between the two is that both the FDM and the SLAs are readily available. The cost of entry is relatively low, and that's kind of important to model railroaders because you don't want to lay out thousands and thousands of dollars to get into this technology. You can usually do it under $500. There's a tremendous amount of YouTube content out there about people that are willing to train you and show you different techniques about how to do things. And almost every month there's a new player coming into the market. From the FDM standpoint, they're relatively easy to learn. So the learning curve is not that steep. But the build volume is relatively slow. If it takes 5 minutes to build one piece, and if you have 10 pieces, it's going to take 10 times that, or 50 minutes. And many, many prints could go for hours. And I've had prints go for as long as 12 hours. I've heard some prints go as long as 24 hours. They have a relatively large build volume. I know on my Prusias, we're talking about roughly 200 by 200 by 200 millimeters, which for most of the things that I build is enough. The material is easy to handle. Once you're finished building something, you can pick it up and you can place it in place right away. The post-processing is easy. except for maybe a little bit of sanding here and there. There's not a whole lot that you have to do. And we talk about supports. Supports are additional pieces of plastic that are added in order to hold things together so that you're not printing in just space. And you need not that many supports with the FDMs. Now, on the other hand, with the SLAs, the learning curve is a lot steeper. It's taken me probably a couple of years to get to the point where I feel comfortable with it right now, but the build is much, much faster. Where I said before that on the FDM, if you have one piece that takes 5 minutes and you make 10 pieces, it's going to take 10 times as long. As it turns out with the SLA printer, if I make one piece or I make 100 pieces on the same build plate, it takes the exact same amount of time. And that's the beauty of the SLA over the FDM. You can cut the build time down by hours sometimes in making different pieces. They usually do have a bit smaller build volume, but I haven't found that to be a big problem. But again, they can get much, much higher detail than you can with the FDMs. The material does need special handling. I've seen videos where people want to wear masks and goggles and gloves. And I can tell you from experience, because, and I talk about post-processing here, I post-process and clean all of my materials with 91% IPA and isopropyl alcohol. And there's been a number of times where my hands actually didn't blister as if there was a sunburn, but they actually blistered and I had to go to a dermatologist. So I wear gloves all the time. And that's one of the big things that I would say to anybody that's thinking about getting into the SLA world is be really careful with this material because it can damage your hands. Now I threw this in there because it's I found it very interesting. There's a company out there called Junko, and I often wonder whether anybody would buy a machine with a name like Junko. It might be a fine machine, but the name would kind of lead me away not to buy it. So here we have a Junko machine, and it's going for about $349. Okay, so the question is, how do we get from here, which is either the resin that you see with the SLAs or the filament that you see with the FDMs over to a final product? And the answer is all through software. It's a 3-step process. It's number one, you have to design it. Number two, you have to slice it. I'll talk about that in a minute. And then you print it. Okay. The design part is basically you build things in a 2-dimensional world. This is a very simple drawing here. And then once you have that 2-dimensional world, you can do something called extruding, which says, okay, I'm going to take that surface and I'm going to pull it out. I can pull it out. I can push it in any way you want to. But you come up with a 3-dimensional object. And that object is then outputted into a file that's called an STL. So a lot of 3D printers will talk about trying to get other people's STLs because that's where the design is. And then once you get that STL, then you're going to send it to another piece of software, which is called a slicer. And the slicer is going to be dividing that piece of that you just created into very, very thin layers and storing those layers and passing those over to the printer. There's a lot of things that you can do with this software. For instance, if I wanted to make a lamp shade like this, you can start out with a 2-dimensional type of drawing like this, and then you can tell the software, I want to revolve that around a given axis, and all of a sudden you've got a 3-dimensional lampshade, and you can do this over and over and over. The biggest thing, and when people talk about the learning curve, is that if you can imagine things in primitives, and by primitives, I mean squares and circles and rectangles, then you can build using those, and then you can blow it out to make anything that you want to make. There's a lot of software out there. The one that I use is Autodesk Inventor. It's a fairly high-end software. Here's some other ones. Tinkercad, I think somebody mentioned that last week. Even though these are very expensive, Autodesk, who is the owner of Inventor, if you can show that you're a student, then you can actually use their software for no charge at all. And for me, it's a matter of going and taking a course every once in a while at my local community college, get my student status, and then I get a $1,600 package that I can use every year. And it's absolutely legal, and it's a great package. And some of the other ones are like that too. Now, the slicer that I mentioned before, once you have the design done, it's going to take and bring in the STL file that you made from the CAD file, and it's going to divide that design into very, very, very thin layers. And once you have it in there, you can do other things. You can scale it. For instance, you could take a figure and go from O scale to G scale. One of the things that I'm doing right now is there's a company in England called Model U, and you can actually purchase STL files of railroad figures from them. So if I can take that railroad figure and it comes in HO scale and also comes in 1/43.5 scale, I can scale that so I can get it to 148 without any trouble at all. And I don't lose any detail. You can position the piece, you can rotate it, you can make multiple copies. You can actually have different segments. So if you want to divide this thing up and print different segments at the time, you can mirror it. Something else that I'm doing with my figures is that if I have a human figure with, let's say, the right arm up, I can take that, copy it, and mirror it. So then all of a sudden it looks like the left arm is up. So instead of having one figure, I can have two figures. And then you can cut and chop. You can cut pieces off anytime you want to. Now, once that's all done, then that program outputs something called a G code. And the G code is actually the machine language that the printers understand. Here's just this is my Prusa slicer. This is where I do a lot of my slicing for my FDM printers. And so it gives me a lot of flexibility. Here's some of the features. For instance, I can split it up into different parts. I can make copies using this function up here. And I can dictate what PL or what filament that I'm using, how much infill. If I have 100% infill, that means, of course, that I've got a solid piece. But if you don't need that kind of strength, you can save a lot of filament by reducing that infill. And then you can do things like rotating it and scaling it down here. This is a plate of the figures that I was showing you. These are the Model U figures. This set came as 5 different figures. So what I did was I copied, and then it came in as 43.5. I scaled them down to 48. And then I copied and made 30 figures. Half of these are reversed. So I can put many, many figures like that on the layout for not too much of a cost. And again, on this one, the resolution is very, very fine. So it's down in the thousandths of millimeter level. Different slicers that are available. The Prusa slicer is one of my favorites. I also use this called Lychee or Litchi slicer. This is the one that I use primarily for my SLA printers. And here's some of the other ones that are out there, just to name a few. Now, if you don't want to go to all the trouble to design your own, there are repository of files sitting out on the internet. One is called Thingiverse. It's absolutely free. There are people that have made things like me and say, I'm going to share that with the world. They put it out on Thingiverse, and then you can download those files and you can use them any way that you want. And some of the other houses that have pieces that you can download, here's that module U that I mentioned. Prusa themselves have something, Prusa Printables, and other companies that can actually allow you to download those STL files so that you can play with them. And if you don't want to print your own, there are companies out there that'll do the printing for you. So you can design and then send that design to them. Shapeways is a very, very popular one, and some of the other ones. Now, these do cost money to use, but they turn out very, very good products. If you want to learn about 3D printers, almost all of them have embedded tutorials. There's a tremendous amount of information out on the web and YouTube sessions. There are paid through courses. One of the ones that I've used is this company called Udemy. And Udemy allows you, they have courses on almost any topic that you can imagine. But the cost is relatively cheap. It might be $20, and then you have a lifetime access to the course. Local libraries, great place to go. I know the local library that we have here in Westminster, Maryland, actually has some of the Prusa 3D printers. And again, all you have to do is take your design to them and take your filament, and then you can actually print at no cost at all. And of course, there's a number of members. I know that Earl does it. I think Phil does it. And there might be some other guys that also have 3D printers. And, you know, I think we all love to talk about that. that's where I'm going to stop for tonight. I just wanted to give you a flavor for what the technology about. Next time, I'd like to talk about some practical applications. And these are just a couple of the things that I've been able to do. For instance, I will never have to buy another window from anybody. So we can make our own windows, and we can make them in any size and any configuration that we want to. Here are some of the dwarf signals that I've been able to produce. This is that lampshade that I showed you that we made, and we can hang on a building. And in one of my most recent projects are these water tenders that go behind my ON30 Climax. And we have sold a number of these. People find them very popular. We started off, and I'm going to blame it all on Steve Sherrill, because Steve actually needed something to pull behind some of his ON30 engines where he could put his batteries and little radio receivers in so he could run his dead rail. So I looked at some of the things he had on his layout, and we designed these and printed these. And there's both a rounded version, this is a rounded corner version, and this is a square version. So everything on these have been printed except for the wheels themselves. So that's where I'm going to stop. I'll answer any questions that anybody might have. And I really encourage anybody that's interested to look into 3D printing, because it's a tremendous way to forward the hobby. And Jim mentioned earlier about trying to get young people in. This is certainly an avenue that might interest a lot of young people. A new technology that we can provide and actually use on an old hobby. So, anybody have any questions?
I got a question, Bob.
Sure.
Tom Farrell.
Yeah.
If you design,
yeah, I got you.
you hear me? Sorry.
Yeah, I got you.
If you do a 3D drawing in like SketchUp or one of those CAD programs, you can't just download that STL file, a direct connection into your filament printer. You have to use a slicer.
You have to slice it, Tom.
So you got to buy it. That's another program.
Yeah, you have to. And for instance, Prusa Slicer is free. There's no charge for that at all. But you do have to take it, and you have to have the software divide the object into those layers. And then that layer, the G code, is sent actually over to the printer.
Okay. So there's, okay.
And listen, I know Bob covered an awful lot of material tonight. And again, you heard me talk earlier in the show about the new Facebook group that we've established. That's why we've established it, because if you go back, Earl will be breaking our shows up, and one of the segments that will be broken up is Bob's segment. And if you go back and you listen to it again, and a question comes to your mind, go to the group and ask the question. Bob can be on the group, he can answer the question there, and it's like a continuation of our show. So that's what the group is for, and for things like the detail and the technical parts of what Bob just went over, that's perfect for what we envision the group Facebook page to be for. Because a lot of people may not have questions that come immediately to mind, but if they look at the video later, something will dawn on them and they'll say, gee, I wish I'd have asked that. Well, go ahead and ask it. Just go to the group and ask the question.
Mm-hmm.
Bob, I really do appreciate it and look forward to part 2 next week. Thank you, Bob.
Thank you, and Happy New Year, everybody.
Same to you, and look forward to seeing you next week for this part 2 of this. This is interesting, I think. I've never heard of the slicer before.